Regents Chemistry Faithful, here we go. Video number 2. I'm feeling like I'm in my groove, making videos. What are the words we need to use and what do they mean? Here we go. Oxidation and reduction. So I like this. This is a perfect picture. Reduction is gaining of an electron. When an atom gains an electron and the oxidation number actually reduces because the charge on an electron is negative. That's where the name comes from. Okay. You're going to learn that there's an acronym to let me know which one's being oxidized and which one's being reduced. I need to use the acronym. Right? Oxidation is when an atom loses an electron, its oxidation number will increase. Okay. Good. Oxidation is another word for rusting, by the way. Leo says GER. This can be the acronym you choose if you'd like. I'm an oil rig guy. You choose. There's 2 of them. I don't care which one you pick. They're both on the front of your packet. This stands for loss of electron, or losing electrons is oxidation. That's Leo. GER, gaining electrons is reduction. I know some people like this one because the word electron is in there. I like to think that this whole unit is about gaining and losing electrons, so it should be kind of obvious. Right? I'm an oil rig guy, so ready? Oil rig. Oxidation is losing, reduction is gaining. That's how I do it. And you'll see me write that right on the top of my paper. Okay. The reducing agent. He's the guy that's responsible for the reduction. So Cl here is being reduced. He's gaining an electron. Reduction is gaining. Oil rig. Reduction is gaining. So the oxidizing or the reducing agent is the Na. And then opposite, Na is losing, so he's oxidizing. So the oxidizing agent is the Cl. It's the opposite. Okay? So the reducing agent is the species responsible for the reduction. It's the one who's actually being oxidized. Okay? This opposite is going to be true for the oxidizing agent. Guess who's coming next? Oxidizing agent. Same picture because they happen together. Species responsible for the oxidation, he's actually being reduced. Beautiful. Okay, oxidation numbers. Here we go. We've done these before. Is a perfect way to assign oxidation numbers. We know how to crisscross. We know how to do these charge cancellation. This is the charge on the ion after it's gained or lost an electron. Could be positive, could be negative. Remember, electrons are negative, so it's going to be a good review from atoms back in the day. Half reaction. Here are 2 of them. Here's the oxidation half reaction. Here's the reduction half reaction. If you take the 2 reactions, put them together, you got the full-fledged reaction. Beautiful. Half reaction is either the oxidation or reduction reaction written by itself with the electrons involved. That's the key part there, where we don't put the electrons themselves in the balanced chemical equation because one's going to gain 2, the other's going to lose 2, so they kind of cancel out. We don't usually keep track of the electrons within the balanced chemical equation. That's why we write the half reactions, and then we balance the half reactions so that the number of electrons gained equals the number of electrons lost. You might have to balance these things. Voltaic cell. Perfect picture. This picture has everything going on perfectly in tune with what's going on, and I hope the simulation works too. You can even see the electrodes, which one's losing mass and which one's gaining mass. Here it shows you why and what's going on with the flow of electrons, the fact that a voltaic cell has a voltmeter. The other thing that it has that an electrolytic cell has, 2 other things, ready? It has a salt bridge, which allows the ions to flow. You got to be able to say that. And it also has 2 containers. Notice there's solution in an electrode in one, solution in an electrode in the other. Major differences in a voltaic cell than an electrolytic cell. The other thing that voltaic cell is spontaneous, which means just what it sounds like. It goes up right away all by itself. So it's a system that spontaneously converts chemical energy into electrical energy. Beautiful. Electrical energy, flow of electrons. This is an electrolytic cell. Notice it has a power source, a battery, and not a voltmeter. Notice it has one one beaker, or if you will, one cell, and it also does not have a salt bridge. So this is also going to be non-spontaneous. So a system that non-spontaneously converts chemical energy into electrical energy, electricity is required to make it go. In other words, I need a power source. Okay, you need a battery, you need something. In those cells are electrodes. This is the metal piece that allows the electrons to flow. It's a conductor that connects the electrolyte solution to the electrochemical cell, allowing the electrons to flow through it. There are two electrodes. One's the anode, one's the cathode, and Angry-Ox and Red Cat are the two acronyms we use to remember which one's which as far as oxidizing and reduction. So the anode, here's a picture. Notice it's positive. This is the electron or the electrode where oxidation takes place. Notice it's the positive one, which makes sense. Electrons are negative. Oh, so this is an electrolytic cell. That's why. That's what forces the negative electron to go to the negative cathode. You wouldn't normally do that. The electrode where reduction takes place is the cathode, and we remember that Angry-Ox, Red Cat. Another set of acronyms. Ready? Angry Red Cat, Angry-Ox. Anode is where oxidation takes place. Cathode is where reduction takes place. Learn the saying, never have to forget it. Okay? Reduction happens at the cathode. Angry-Ox, Red Cat, Angry-Ox is how we say that. That's how I learned to say it anyways. Salt bridge, muy importante. This is that orange piece. Do you see the ions going back and forth and back and forth? They actually go in both directions. So pay very careful attention to the simulation in the lab. It really helps you. Enable ions to flow between oxidation and reduction half cells. Okay, good. Enables ions to flow is the key piece. I see this on the reference or on the Regents exam all the time. What is the purpose of the salt bridge? The truth is to let ions flow. The other thing you can do that is correct is to complete the circuit. You could say that, but it allows ions to flow. Spontaneous reaction. Okay, a reaction that proceeds by itself, no energy required. It's spontaneous. Pop, happens. Doesn't need any help. Doesn't need a push. Non-spontaneous reaction. This is like charging your cell phone or your laptop or your Chromebook, right? You have to force it to happen. This is a reaction that requires energy to make it go. Okay, you have to have a power source. You have to plug it in. Anion. We've heard of anions before. Anions are annoying, therefore they're negative, therefore they've added an electron. An atom that has gained an electron, it's a negative ion. It's annoying. It's negative. Cation, opposite, lost an electron. An atom that's lost an electron, now he's positive because who's winning the game? Protons. Lost an electron, protons is winning. Protons is positive. We've done this before. And look at that. We're done with our vocab. Study your words and take your test.